Welcome back, and in this video I'm going to try to finish the checklist of important points. Okay, so if I want to talk about where the vertices are, I can see where these points are. They're physically on each of the parabolas of the hyperbola. But more specifically, this vertex is going to be the point A, comma, 0. And again, we're using that letter A because A is going to help us find the vertex. That would mean this point here is called negative A, 0. Okay. Now, the focus points are going to be at C0, and this point here is going to be negative C0. Again, focus points are using the same letter that we learned before. And finally, the covertex, you probably guessed it, it's going to be the point 0B, using the same letters as the ellipse would use. And this point here would be 0, negative B. Okay, so you can kind of see where these are, the vertices, the covertices, and the focus points. Now, a couple things to note. In this type of conic section, in the horizontal hyperbola, to find the foci, or the focal points, the equation's a little different. It's going to be c squared equals a squared plus b squared. Okay, notice there's a plus there. It's actually slightly different than the ellipse. The ellipse formula, there's a minus sign there. And honestly, the way that I remember this is I know that in an ellipse, there's a minus sign here. So it's the opposite for the foci. There's a plus sign here. Okay, and then that would mean that c would equal plus or minus the square root of a squared plus b squared. Okay, so let's just talk about quickly what A, B, and C stand for. So A is going to be, you can probably see, it's going to be the distance from the center to the vertex. Okay, so that's what I mean by the letter A, right? And I could get that by coming up here and knowing what A squared is. It's the distance from the center to the vertex. What's B? Well, B is the distance from the center, okay, to the covertex. And hopefully that sounds logical. And then finally, C is the distance from the center to the focus point. Okay, now we've talked about A, B, and C. We're going to talk about the transverse and the conjugate axis. So think about what it means to transverse, right? Transverse means to sort of cross through. So the way that I remember this is I remember that it's the axis that crosses through the hyperbola. So in this case, the x-axis, right, since the x-axis is going through the hyperbola, is the transverse axis. So hopefully that makes logical sense. And there's nothing really to note there other than what it's called. Again, I always remember if I start with an x, x is horizontal, so that means I'm a horizontal hyperbola. The x-axis is the transverse axis. And then I remember the conjugate axis is just the other one. So that would mean in this particular case, the y-axis is the conjugate axis. And again, the only really reason to know that is just to kind of understand how to draw the parabola, okay? So other than that, the only other thing that you're going to want to know how to calculate are the slopes of these asymptotes. And I won't really ask you to draw these to scale. This is very hard to draw, but just for your reference, the slope, which I'm denoting by the letter M, is going to equal plus or minus B over A for a horizontal hyperbola. And you can kind of think that that makes logical sense, right? If the if the points on the y-axis are b and the points on the x-axis are a, slope is rise over run, change in y over change in x. If you wanted to find the slope of these asymptotes here, it would be plus or minus b over a. You can see one is a positive slope and one is a negative slope. So I hope that gave you a good overview of the components of a horizontal hyperbola. Again, you want to make sure that you have all of these features in your notes, and that way when it comes time to do actual examples, you can use this as a reference point. So just make sure that you have everything written down very carefully and that you watch this as many times as needed. I will see you in the next video where I will explain a vertical hyperbola.